we've already talked about polygons quite a bit, actually. What is a polygon? Okay, so your sides have to connect. Carly? No curved sides. There's one more rule. Carly? She said that already. Said it has to close. And they can't cross. Okay, so the shape has to close. The lines cannot, or the sides cannot cross, and the sides cannot be curved, right? Okay. What's the difference between convex and concave, Travis?
Convex is convex is like where it's not sort of having an upward angle into the shape, and then
Right. So convex does not cave in, for lack of better terms, right? And concave does cave in. Okay? And then what is the difference between regular and irregular polygons? Like those ones right there on the side. I don't know what you're talking about. Yeah, but how do you know? What's that? Congruent angles and sides. Remember, if something is regular, it's both equilateral and equiangular. Okay, so irregular would not have the same angles and side measures, right? Okay, so on 11.1 today, we're talking about angle measures in polygons. We know a triangle has how many degrees? 180. Is a triangle a polygon?
No.
Yes. It has straight lines, straight sides, it closes, and it has no sides intersecting each other. Is a quadrilateral a polygon? Yeah. As long as it doesn't have a curved side, right? Okay. And it has how many degrees on the inside? 360. Hey, those are your two common ones. Anybody know how many degrees a pentagon has on the inside? See, now it's just guessing, right? First two theorems are going to help us out with that. So, our first two theorems, I would make on your theorem sheet a category called polygon, interior angles. And then we'll do theorems numbers 1 and 2. Okay, we have to be very careful and pay close attention to the wording on these, because the wording is going to give away whether we can or cannot use these. The sum of the measures of the interior angles of a convex n-gon, n-gon just meaning any number of sides, polygon, right? So it could be a 30-gon, it could be a 90-gon, it could be a 8-gon, which would be an octagon. Okay, whatever. N just means number of sides. Okay, so the sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180. Again, n stands for what? The number of sides, which is going to be the same as the number of angles, so it just depends which one you want to count. Now, there are some key words in here that are important for us to understand when we can use this, or when we are going to want to. One of them is sum. And that kind of goes with sum of the angles. What does that mean? I mean I'm adding all the angles together. Okay, so Does this theorem tell us what each individual angle equals? No, it tells me what they all equal together when they're added, right? Okay, so understand that. This doesn't give you one angle measure. This gives you all of them added together. Okay? This is also very important. Convex. Can it be concave? No, this doesn't work. Does it say that the figure has to be regular? No. So could this be an irregular polygon and this still work? Yes. Okay. So you might have some completely random shape up here. As long as it does not cave in and it is a polygon, this applies. Okay. Before we do an example, I'm going to go ahead and get theorem number 2 down for us. Number 2 says that the measure of each interior angle of a regular n-gon is n minus 2 times 180 divided by n. What are some key words out of this one? I heard somebody say each angle, right? That's probably pretty important. So in this theorem, what am I finding? I'm finding each angle measure, right? Not all of them added together. I'm finding each one individually. What else is important out of here? It must be regular. So in an irregular shape, does this work? No. And the reason for that is because are all the angles going to be the same in an irregular shape? No. But in a regular shape, they're all the same, right? So once I know, notice that right there is going to give me all of the angles added together, right? So once I know that, if it's regular, I can just divide it by the number, or how many there is. Okay, so there's your 2 theorems for interior angles of a polygon. Okay, we'll do 2 examples here for that. If it's concave, you have no idea what the interior angles add up to. Because that it's going to have that one angle that's over 180, which isn't really an angle. An angle can't really be over 180 degrees. Because once you hit 180 degrees, that's a straight line, right? Okay, so let's say we're talking about the top angle. Well, once I go more than that, that's not really your angle anymore. Your angle's really down here. So it's still less than 180. That make sense? A little bit? Okay. Alright, so the example that they give us, different than what you guys have in your book. My diagram isn't completely accurate, but it's close enough for what we need. They give me this. They want to know what's the value of x. You have to understand what you have drawn and which theorem you can or cannot use. Can I use the first theorem?
Yes.
Yeah, because is that a convex polygon?
Yes.
Okay, it's a convex polygon, so I can use that. Can I use the second one?
No.
Why not, Taylor? It's not regular. Okay, and it's obvious it's not regular because all these random angle measures, right? Okay, so the second theorem's out. So could I find each angle individually right away? No. But using the first theorem, I can find what they all together add to, right? And if I can find that, can I figure out what x is? Yeah, because I know the rest. So how many sides are here? 5. So when I set this up, I have 5 minus 2 times 180. And I know most of you probably won't set that whole thing up. But so then I have 3 times 180, which is 540. Okay. So that tells me that a 5-sided figure has how many degrees on the inside? 540. Now how do I figure out what that one is? Add all the other ones together and subtract it from that. Or just subtract it individually, right? I like to subtract individually. It doesn't matter, though. You're going to get the same answer. 84. X equals 84. Okay. Be careful what they're asking for. If they are asking what is the measure of the angle, you need to have degrees on there, right? Okay, some of you missed some points on your test because they asked for angle measures and you just put a number. Okay, if it requires a label, make sure that label gets put there. Okay, in this case, if it says what's the value of x, do you need a label? No. If they ask for the value of x and you give me this, I'm not going to count off for that, though. Okay, having a label is not going to be wrong as long as it's a proper label. Okay, but if it requires a label, it must be there. Alright, the next problem is a little bit different. Okay, so obviously we use the first theorem on that one. So logically thinking, you're probably going to use the second theorem on the next one. But the second theorem tells us the measure of each angle, right? Okay, they're not going to ask for that in this problem. They're going to tell you what that is. Okay, so they tell you that the measure of each interior angle of a regular polygon is 165 degrees. They want to know how many sides does that have? So what were the giveaways that you're going to use that second theorem? Yeah, it tells you, where's that word at? That it's a regular polygon, right? What else? Each interior angle. Okay, so I'm finding, or have been told, each interior angle of this regular polygon, correct? That should be a dead giveaway to use that second theorem. What is that equation? Because you're going to need the equation no matter what. Jacob? Just in the theorem.
Oh, n minus 2 times 80.
Okay, so that's the theorem, or the equation given. I guess that's not an equation, but it's the expression given to us in the equation, right? And I know in the equation, that tells me what each angle is, correct? Jacob, finish this out. Equals 165. Because didn't they already tell me what each angle equaled? Yeah, so it wouldn't be equal to x or whatever. It would be equal to 165 because that was what they told me. Now this is where in the last couple classes we've got a little stump. How do I solve this? That's an option. I wouldn't do that yet. Why, McKenna? Well, right now I'm dividing by n, right?
Yeah.
And everything's harder when there's a fraction like this. Okay, so let's get rid of that fraction, because if I'm dividing by n, if I multiply by n on both sides, that goes away. right? Because they would cross cancel. Okay. So now I have n minus 2 times 180 equals 165n. Now most of us can start solving this. What would I do next? What do you think, Vincent? No idea? Not even a guess? Amanda? I'd distribute. Now, some people in the other classes have said, well, can't I divide by 180? Could you do that? Yeah, you could do that. Okay, you could divide by 180 because you're going to multiply it to both of those anyways. But that's going to give you a fraction over here. Okay, so that's going to be a little bit more difficult this time. So just see if it's going to work, if that's how you want to do it. But I do distribute. That'd be the easiest. So 180 times n is 180n. 180 times negative 2 is negative 360 equals 165n. Now there's a lot of ways you can solve this from here. I personally like to subtract my 180n because I already have an n on that side and a number on this side. So I get negative 360 equals negative 15n. My two negatives on opposite sides are going to do what? Yeah, because I'm going to divide by negative 1 on both sides. So they're going to change positive. So I actually divide by 15, and n equals, like Jacob said, 24. Now, is a label required here? What did they ask me to find? How many sides? So what would you put here? Sides. There's 24 sides. If you just leave it as 24, I don't know what that is. Maybe that's the angle measure. Maybe that's the side length. Okay, give me a label if it needs it.
So now there should be no like decimals or anything.
Yeah, you'll never get a decimal for that in that scenario. If they told you the number of sides and you found an angle measure, maybe. Right? But yeah, you can't have part of a side. That'll always be a whole number. Questions on the first two theorems? Not too bad. There's a little bit of setting up equations that you do have to worry about, though. Okay, the next two theorems are actually easier. But before we do that, we need to make sure we understand what an exterior angle is. Bless you. Is this an exterior angle? No. That's a what? Interior angle. Is this an exterior angle? And that. And that. And that. And that. Those are my exterior angles, right? Okay, just so everybody's on the same page. Alright. Polygon exterior angles. These ones are going to be pretty easy for you. The sum of the measures of the exterior angles of a convex polygon, they just say polygon. I'm going to say angon. One angle at each vertex is 360 degrees. is there any computing or anything that you have to do here? No. What is the measure of all the angles added together? 360. Does it matter what shape it is? Does it matter how big it is? Does it matter if it's regular? No. Does it matter if it's convex, concave? Yeah, that matters. But otherwise, none of it matters. Okay, so just make sure you understand, okay, your keywords are, again, are sum of the angles, right? So this is all of them added together. It's not each one individually. Okay? And it does have to be convex. Okay, so all your exterior angles added together of a convex shape is 360 degrees. That's a little easier to remember. There's no expression you have to remember. Second theorem. The measure of each exterior angle of a regular angon is, how are you going to find that? What do they all add to? So if they're all the same, then you divide it by n, however many there are, right? The measure of each exterior angle of a regular angon is 360 divided by n. Your keywords are what? Each angle and regular. So are you finding each individual angle in that one? Yes. Alright, example 3 part A, I'm not going to draw out for you guys. Let's take a look at that real quick though. Is that a convex polygon? Yes. So, could I use this theorem and find the sum of the exterior angles? What's it going to be? 360. Okay. Now the question is it regular? No. So can I use this one? No. Do I have enough information, or do they give me enough angle measures to figure out what x equals, though? Yeah, because when I add all of those together, they should equal what? 360. So, correct me if I get this wrong. I believe my numbers are x, 2x, 2x, 3x, and 4x, right? And those should all add together to equal 360. So then from there, you combine your like terms and divide. And you figure out what x is, right? Okay, that one's not too bad. Real quick, last example. Notice that has the one I selected has 12 sides. Usually they will tell you or give you markings that it's regular. Hey, I'm just going to verbally tell you that this is a regular shape. Seth, how do I figure out what that exterior angle equals? Yeah, because all of the exterior angles added together must equal 360. And there's 12 of them, so each one has to be equal. So I divide by 12, x equals 30. Okay, again, correct me if I'm wrong, but I feel like exterior is a lot easier. Okay. Questions on any of that? Okay, that's all we got for section 1 out of this chapter. Okay, obviously we'll keep moving on. If you're going to be gone this week, make sure you're staying caught up on everything. All the lessons will be online.